Okay, let's start doing some more problems. So let's find the area of the region bounded by y equals sine of x, y equals x equals pi over 2, and x equals pi. Okay, so again, I am going to insist that you graph these things. And again, I know that plenty of you aren't going to graph it and get points taken off of your exam when you didn't need to have. Okay, all right. Sine of x, we know how to graph that. Okay, and if you don't know how to graph that, I'll go ahead. You can look on my YouTube channel in the pre-calc. There's graphs of sine and cosine. I have those videos there. Okay. You need to ask me. I will send you the link. Okay. There's y equals sine of x. Okay, y equals x. This is a little bit tricky because we don't know whether y equals x is above or below sine of x, okay? Because they start out basically the same, okay? If you remember, sine x over x as x goes to 0 is 1, okay? But we have a trick, or we have something in our favor. We're doing this from pi over 2 to pi, okay? Well, when x is pi over 2 is roughly 1.5, which is bigger than 1. So look at that. We can make it go like so. Let me make it a little lower. Like so. So y equals x actually lies above the curve. It's not a bounded region yet. That's why we needed these things. Okay, let me fill that in. This is what we're finding. Okay, so as an integral, the integral from pi over 2 to pi, okay, x minus sine x dx. Okay, all right, not a hard integral to do. I'll leave that one for you guys in case you need to look at it a little more. Okay, let's do another one. Find the area of the region bounded by 4x plus y squared equals 12 and x equals y. Okay, now this one, what makes this one a little special is that this is x not as a function of y, or I'm sorry, y not as a function of x, but x as a function of y. Let me write that down for you. Okay, that comes from this. Okay, so we're going to write that as, we're going to solve that for x. So x equals, 3 minus 1/4 y squared. Okay, so now we have x equals y and 3 minus 1/4 y squared. You're going to get tired of hearing me say it, and I'm going to get tired of saying it, but I will insist that you graph these things. Okay. One of the things I love about doing things on the iPad or something similar is I can do things in different color. I guess I could always do that, but now it's much easier. There's x equals y. X equals 3 minus 1/4 y squared. 1, 2, 3. And then it's going to be a parabola opening to the left. Normally, I wouldn't have been so perfectionist about the line, but everything else was drawn so perfectly, I just wanted to have that. Okay, so we need to find the points of intersection. Okay. So, and one thing I should have said here, I did upper minus lower. I should have also said right minus left. Because in this case, we have right minus left. Okay? So we're going to take, this is the rightmost one, and that's the leftmost one. So we're going to do the integral. We don't know where to where yet. 3 minus 1/4 y squared minus y. Okay, but it's not going to be too hard to find these points of intersection. So let's say, I'm actually going to do it by saying 4x plus y squared equals 12. And I'm going to input x equals y in there. Okay, so I'm going to get 4y plus y squared equals 12. Let me change the color on that. Okay. Let me change the color there. Okay, I can factor out a y. Not what I wanted to do. Let me put the 12 on the other side. Now I can factor this. This is going to be y minus 6 times, actually y plus 6, y minus 2. So y equals negative 6, or y equals 2. So this point here, I don't even really care what the x value is. Well, it's 6 because this is y equals x. So it's not 6, but negative 6, negative 6. And this point here is 2, 2. Okay? All right. I'll see you all in the next video.